should have. I had recorded a little lesson, tiny lesson, real short, just 3 examples on division. This obviously is not division, it's multiplication, but really if you understand multiplication, you can do division too. So there's a little curveball on this one. I say remember the opposites thing. And so y'all take a couple minutes, work through this warm up, simplify this out, and then we'll get going. As this problem gets underway, I'm seeing a lot of people that are factoring it out. That's good. Our first step is factor the top and bottom of each fraction that we can. And factoring's not always easy. So sometimes I like to start with the easy ones, like if you see a difference of 2 squares. That might be a good spot to start on. That's kind of an easy factoring technique. If you see the magic method, maybe you hold off on that one if that's something that challenges you. So like on the top left and the bottom right, those are both magic methods. Right? Everything is a product. Once you have factored something, just real quick before you move on to the next thing, double check that you did it correctly. FOIL your result back out. See, did I do that right? You're not done yet, obviously. Most everybody's pencils are still moving. Can I start asking though? Like Andrew, can you tell me how you factor the top left? What were your 2?
I got C plus 2 and 4C minus 1.
All right. So C plus 2 and 4C minus 1. Okay. James, do you have the bottom of the first fraction factor?
1 plus C and 1 minus C.
Very good. Minus C. Y'all check and kind of see how yours are factoring out. See if those stack up. Those are both correct. Okay, Luke, do you have the top right fraction factored out? Yeah, what about you, Jack? Big B. All right, so C minus 1 and C minus 1. I like how, normally we would, what kind of trinomial is that, class? That's perfect square trinomial, right? First term's perfect square, last term's perfect square, middle term's combination, 2 times their square roots. All right, we've done about 100 of those, right? So we usually would write that out as C minus 1 quantity squared, but because we're probably going to be canceling something, it's nice, as Jack did, to express them right next to each other. Or if you just forgot a PST and you thought, well, maybe that's a regular trinomial. What are two factors of 1 that add up to -2? You say, oh, -1 and -1. So they factor out accordingly there. Let's see here. Drew, do you have the last one done? C plus 4. All right, very good. So your first step is factoring, right? If you don't get through all the factoring, then you won't figure any of these problems in this chapter out at all. I promise you that. So guys, I'm telling you now, if you struggle with factoring, you've got to practice. You've got to practice. It was in the last chapter, but you could go back in the last chapter and you could find some of those homework pages in our text where they've got, like 500 questions in that chapter. And you can pick some that have the odd answers in the back. You can practice. You could go to Khan Academy and just type in factoring, and then he's going to have just a crap load of videos and factoring practice problems for you to look at. You can go on Delta Math with all of the homework assignments that I've been giving my freshmen. Guess what? They're all assigned to you guys. Practice, practice, practice. Don't let it slip through the cracks, because you will not succeed in this chapter without being able to factor. I can promise you that. All right, George, pick me a pair now that we can cancel out from top and bottom. You see any identical factors on the top and on the bottom? Good. 4c minus 1 on the top and 4c minus 1 on the bottom. Now, if you don't have your wits about you this morning, you might be tempted to think, oh, that's it. We're done. There's no more identical factors up there. Okay. However, what did I say over here in red? Okay, what do I mean by opposites then? Is there a pair of opposite factors up there? Paul, what pair do you see? Very good. You guys, 1 minus c and c minus 1 are what we call opposites. We discussed this in class, right? A, come on now, where are you at? A, there he is, minus b and b minus a are opposites. And if you don't know what that means, just plug in a couple numbers for a and b. Like I think I used the example in class the other day. What's 5 minus 2? And what's 2 minus 5? -3. Those are opposites. They're not conjugates. No. Opposites. Conjugates would be like a plus b, right? So we know the difference between an opposite and a conjugate by now, or at least we should. So the point to be made here is that, check this out. Look at those two factors that was it Paul that Paul mentioned for us. Okay, I'll highlight them in yellow. This factor right here and one of these factors up there are opposites. And you can factor out a -1 from either of those, and then it becomes clear which way to cancel. I'll show you on the bottom since I got plenty of room there. All right. If I were to factor out a -1 from both of those terms and just set it on the outside of the parentheses, okay, then it would become, instead of +1 minus c, it's going to be -1 plus c, right? When we factor out a negative, it changes the sign of each term in there. How do I know if I did it correctly? Use which property? The distributive property. Just distribute, multiply -1 times -1 and -1 times positive c, and bada bing, bada boom, we get back what we started with, okay? And so now this denominator, and don't forget there was the 1 plus c up at the front, this denominator now, it has that common factor that I could cancel. You say, whoa, wait. It doesn't look the same. What other property should I use then? Good, the commutative property. Because -1 plus c is the same thing as c minus 1. Just rearranging those terms, maintaining their signage. Okay, so we could definitely cancel out c minus 1 and c minus 1. Now, that being said, okay, let's whoops, where'd we go? I'm going the wrong direction. That being said, let's take stock of what's left over now. Okay, so there's a c plus 2 up top. There's a c minus 1 up top. Okay, there's a 1 plus c on the bottom. I'm going to go ahead and write that as c plus 1 just because I like to have my variable listed first if I can. There's a -1. I'm going to just put that as a negative right there.
Okay, so we've done this, we've done this, we've done this, we've done this. What else is there? C plus 4, good. C plus 4. Okay, now there's a lot of different ways we could write that answer. You know, I put the negative down at the bottom. Somebody tell me where else the negative could go. Jack? At the top or out front, you know, like in the middle. Or if you wanted to get real froggy with it, you could just distribute the negative. But that's dangerous because sometimes we get all crazy and we over distribute. We distribute it into too much. We say, I'll just apply the negative to everything on the bottom or everything on the top. No, it's probably safest just to keep it out. But there's probably 4 or 5 different ways we could write this answer. Okay, suffice it to say, it's important that we factor first, we cancel out common factors, and then we express our answer in a good form. Okay, notice I didn't distribute, I didn't FOIL, leave my answer in factor form. That's the way to go. Any questions that you guys want to ask now? Tiago? Yeah, absolutely. Okay, so the question is, how does this top left trinomial up here factor? Let me clear a little bit of this stuff out of the way. And I like to consider this to be what we would call like a magic method question, okay? So I see a leading coefficient other than 1, okay? It's not a perfect square trinomial because that 2 is not a perfect square. So I'm going to start by multiplying 4 times 2 and get 8. That 4 is going to disappear now from the front, and I'm going to pretend that it is this problem instead, okay? 4 times 2 is 8. Turn it into 8. I'm going to pretend like it's this. This should be an easier problem to factor now because the leading coefficient is no longer 4, it's 1. And so I know this is a regular trinomial, what I like to call a regular trinomial. So I'm just looking for 2 factors of -8 that add up to +7. And what are those? 8 and -1. Now I wrote this up rather poorly. I needed to leave myself a little bit more space than that, didn't I? All right. So what did we have? We had C. And the reason I want to leave a little bit more space is to sneak that 4 back in there. He disappeared. Now he's going to reappear in these 2 places. And then we said if there's any common factors now between the terms of each binomial, just get rid of it. So like that 4 and that 8, right? 4 goes into itself once, goes into 8 twice. That's C plus 2, and 4C minus 1. There was no common factor on the other side. And so that way, I've got it factored out. I could double check myself, foiling it out. There are other techniques that we could use. We've talked before about guess and check. We've talked before about the British method, and then this is called the magic method, and I like it the best. Okay? Just take some practice. Practice, 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 practice. Dr. Suzuki says never be lazy, just practice and practice until you go crazy. Speaking of the magic method, has anybody seen The Prestige yet? I gave y'all that some homework a couple months ago. Anybody watch that yet? I hate you all. Okay. Oh, Charlie, you did? That oh boy. What'd you think about it, Charlie? Did you like it? It's pretty good. Anyway, that's factor. Other questions? Thank you, Tiago. Other questions that y'all might have? All right, all right. Now, how did the video go where you guys saw these 3 examples? Is it pretty straightforward? Anybody want to be bold and say, Coach, I didn't watch the video yet? Okay, a couple of you guys. Oh, a lot of you guys. Oh, ooh. You're going to be in trouble now. You're going to be in trouble with the capital T, and that rhymes with P, and that stands for fool, you people, you uneducated boobs. All right, let's do this. Let's do this. Since not everybody watched the video, shamefully, I'm going to pull up some homework questions. Yeah, look at that. 54 looks like a good one. Let's look at number 54. Now, those of you that did watch the video, gosh, hold on. OneNote's going crazy on me. Those of you that did watch the video, you will be at a distinct advantage now over your lazy classmates. A division problem, or rather a fraction, is another way of saying we got ourselves a division problem, okay? So you might look at this and you might think, gosh, dog, that's insane. That looks nuts. You got 1, 2, 3. You got 4 lines of like trinomial, binomial, binomial, trinomial. What is going on? This is just a big fat division problem, okay? Looky here. That line, that big fraction line that I just highlighted is a division sign. That's like saying, you know, A over B is the same thing as A divided by B. That's all that is. That big fat division sign, or big fat fraction sign, is just a division bar, a division operator, okay? That's all it is. And so what we can do is we can ask ourselves a question, okay, well, what is my, let me get my color that I wanted here. There we go. We'll do it in green. What is my dividend and what is my divisor? Now, the dividend is the thing that's up at the top of our fraction, right? The thing that, if you were doing long division, be inside the house. In other words, my dividend here is going to be that top fraction. 4d squared plus 7d minus 2, or 35d plus 10. All right. What's the divisor? What's the fraction that would be on the bottom? D squared minus 4. 7d squared minus 12d minus 4. Okay? That's all it is. Okay? One fraction on top of another. We got fraction on fraction action. Just write it out as a division problem. And then what do we know? Mossy, dividing is the same thing as multiplying by. It's an R word. The reciprocal. Nate, what does that mean? What does that R word reciprocal mean? Yeah, buddy. So if I'm supposed to be dividing by this fraction over here, d squared minus 4 over blah, 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 blah. If I'm dividing by that fraction, read what's that the same thing as multiplying by? Yeah. We said that. I'm literally wanting you to tell me what to write up here. All right. So we just flip that fraction and put the 7d squared minus 12. What is wrong with me? Minus 12d minus 4. Put it up top, and we change it to it. And now, how now, brown cow? It becomes just like the last problem, doesn't it? Same exact problem. Factor, 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 cancel, 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 cancel. Okay? And that gets boring after a while. But that's okay. Practice sometimes gets boring. That's where you challenge yourself. You put yourself on a clock or something like that. If you're bored, you push yourself to be more efficient. If you know what to do, now see if you can do it quickly. Like down here at the denominator, I got a 5 I could take out, and I'd be left with 7d plus 2. Now I've got a sneaky suspicion. I look at the top right-hand corner and I see a 7d squared, and I think, ooh, you know what? That's going to be magic method, but watch this. This is what I like to call forced factoring. I'm going to gamble. I'm going to take a bet that because 7d plus 2 showed up down at the bottom left, and because that leading coefficient is 7d squared, or that first term up there is 7d squared, it's going to have to be 7d as one of the first terms. I'm going to take a gamble. I'm going to say plus 2. Now it becomes way easier to factor because 7d has to multiply by d up front, and 2 has to multiply by what up at the back? Negative 2. And then I just check. The outer gives me negative 14, the inner gives me positive 2, and I've got that one factored magic method style without actually doing the magic method. That's called forced factoring. These aren't the droids you're looking for. Factor this way because I want you to. All right. Now I see a d minus 2, and I think, ooh, look at the denominator. That's the difference of 2 squares. D plus 2, d minus 2. Okay. And then I come over here at the top, and I think, you know what? I gambled once, and I won. Let it roll. I'm going to say d minus 2 is probably going to be another factor up here. Maybe, maybe not. I don't know. Maybe d plus 2. But I know the other one's going to be 4d. And I get to thinking, oh, okay. What times negative 2? So there's probably going to be a 1 involved. And then I do a real quick outer and inner check, and I think, oh, gosh, dog, I got my signs wrong. Because if I do the inner right now as it stands, that's negative 8d. I'm going to need a positive 8d. So I can switch my signs around that way. And I get a positive 8d, a minus 1d. And I did you guys notice that? I didn't do any factoring other than the GCF right down here. That was the only legit factoring that I did. The rest of it was force factoring. factoring the way I wanted it to, just because I knew stuff cancels out. And in the real world, that doesn't always happen, does it? Okay, but here on a homework problem, how do you think they write these homework problems up? With what in mind? We want stuff to cancel. We want little Johnny to practice canceling some factors out. So we're going to make it such that the factors repeat, okay? And then you're like, oh, wow, that makes a lot more sense. Okay, now they won't always cancel out, right? Let's see what else cancels. There's a D plus 2 and a D plus 2, and oh my goodness gracious. Look at what my answer boils down to. Just a nice simple 4D minus 1 over 5. Textbook writers love to do that. Okay, whatever textbook you're using, if you're using that orange book that I'm so familiar with, guess what they do in that book all the daggum time? They have stuff cancel out. Okay, but that's a real good example. If you didn't watch the video, it takes you through 3 more examples that look just like that. Okay, of division. And what did we say class division is defined as? Multiplying by the reciprocal. Silly fraction, don't be shy, flip yourself and multiply, or whatever that little stuff is that y'all talk about. Keep, change, flip, or keep, flip, change, KFC. Have y'all got into all that with your teachers yet? Y'all haven't done any kind of fraction work this year? Or in past years, like with easier fractions? Okay. All right, now that being said, let's wrap this lesson up. Wrap it up like a burrito here. You know, the key to a burrito is keeping it snug, folding the corners in so you don't leak out the sides, right? Are y'all good burrito makers? No? James, does your burrito always fall apart? You don't make burritos? That's all good. You know who's got a strong burrito game? The people at Moe's. Welcome to Moe's. They got some strong burrito game up there. This week, Christian Brothers is doing a Twitter poll. Who has the best burrito game in town? Is it Moe's or is it Chipotle? And so people are voting on Twitter. If you go on the BLC Twitter page, you too can vote and see who wins. What do y'all think? Do y'all eat at Moe's or Chipotle? Maybe if I want diarrhea, coach. Yeah. No? I'm a fan of the Moe's. I'll get the Moe's. They make some good nachos, and they just pile on all the goodies on top of there, and it's like a gut buster. Okay. Although with most things in life, their nacho tray used to be bigger. They made it small now. They cut it down by a little bit of size, but oh well. Oh well. All right. On the screen, obviously, we need to revisit this topic of domain and range. Which one's which? Domain is the set of X values. Range is the set of Y values. Okay. Now, if there's not an X and a Y, if you're using some other letters or if you're in another context, just remember that domain is the set of inputs, what you're allowed to plug in. All right. And range is the set of outputs. Now, what am I not allowed to have happen on a fraction? What did we say will jack a fraction up? We said this at the beginning of 7.1. What do you think, Jack? I called you Jack. Sorry, well. The denominator of 0 will completely jack you up. That Jack was on my mind there, I guess. We cannot divide by 0. That's bad mojo. That's undefined. So we restrict from our domain any roots or zeros of the denominator. Okay, but we want to do what first before we consider the roots of the denominator? What do we always do first? What do you think, Luke? A little bit louder. Yeah, we want to factor, not just GCF, but any old factoring technique. I'll roll it back to the last time you and I were in person. And what did we say? What did we say to do first every time, no matter what? We want to simplify. Simplify, simplify, simplify. That means, as Luke just said, factor, and then see if anything cancels. And once you have factored, and you are determining if anything cancels, whoops. There we go. Then you are ready to go. So it says set the denominator equal to 0. No, 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 no. The first thing I would like to do is see if anything factors, okay? So Ben, does that numerator indeed factor? I think Luke has hinted at how we will factor it. What did he say? What kind of technique did he suggest? So what's in common between 2x squared and 14x? There's a 2 that goes into both those numbers. And what about a variable? There's an x. Good. So don't, and again, fellas, don't feel the pressure to do it all at once. Just take it number with number and letter with letter. Okay? Quentin, what's left over when we take out that 2x? What kind of 7? And Lewis, how do I check to make sure that Quentin didn't mess that up?
FOIL it back out.
Yeah, we just distribute 2x. 2x times x is 2x squared. 2x times 7, or 2x times negative 7, rather, is negative 14x. So very good. Ben and Quentin, thank you. Now, down at the bottom, okay, down at the bottom, Grove, is there a GCF? There sure is. What is it?
4.
We'll take out a 4. All right, and Alex, what about left over with, Mr. Went?
X squared. 4.
That's 4x minus 12. Okay. Oxley, you want to factor that trinomial out further, please?
X minus 6.
Atta boy. X plus 2. I'll write it over here. X minus 6 and x plus 2. Now, does anything cancel out here? What? Yeah, a 2. A 2 cancels out. And that's not going to affect my the roots of my denominator at all, but it will make my fraction a little bit nicer, right? So we could rewrite f in simplified form as x minus 7, and then 2, x minus 6, and x plus 2. All right? So that's what a good first step looks like. Factor everything, and then see if anything cancels. Now, Joey, what did we say? We'll jack up the function. I think Will just said this a moment ago. If we divide by 0, very good. Okay, so do we see any roots of the denominator? What are those roots? Call them out. 6 and negative 2. Therefore, those will be my restrictions. You and I talked about restrictions on Monday, didn't we? Or maybe it was Tuesday. Those will be our restrictions from the domain of this function. In other words, I cannot have x to equal 6 because f of 6 would be undefined because the denominator would be 0. I cannot have x equal negative 2 for the same reason. All right, so we would say the domain is all real numbers. Let's write this up. Domain x is a member of the set of real numbers. X could be anything we want it to be, except, so we would say x cannot equal 6 or negative 2. Okay, do we remember that notation, right? What's this little squiggly e, curly e look like? It means is a member of the set. And what does this little double R, the scripted R, mean? The set of real numbers. So this just means x could be any real number you want it to be, as long as it's not 6 or negative 2. Okay? By the way, I'm going to follow this up by saying, follow-up question. Can I write it up here? Yeah. Where does f of x equal 0? So on Tuesday, maybe Monday, we talked about how the denominator 0 makes the function undefined. So what value do you think we would plug in, Jack McBee, to make this function equal 0? 7, okay. Anything else? 0. Because the numerator was quadratic, just like the denominator was, fundamental theorem of algebra says there's going to be how many roots to the numerator? 2. There's going to be 2 roots. So if the function's numerator, when you simplify it out, has 2 factors in it, like we said, there's one, there's the other, okay, then it's going to say, oh, well, there are 2 roots, x equals 0 or x equals negative 7. Graphically speaking, what do we know roots are? Also known as solutions, also known as zeros, also known as x-intercepts. Very good. So what you just found about this rational function is you found where it's undefined. You'll learn in Algebra 2 that's where it has either a hole or, in this case, a vertical asymptote, okay? So like you'll learn in Algebra 2 that this function has, you know, a vertical asymptote, which is like an imaginary boundary line right there at -2, right there at +6. It would have a horizontal asymptote too. You'll learn that later on. But check this out. Look, what did we just found? We just found that it hits the x-axis at 0 and it hits the x-axis at 7. Okay, so this curve behaves in a very strange manner, but you'll learn that in Algebra 2. And the powerful thing that y'all are able to do as Algebra 1 students is to determine where is the function undefined. That's where it's going to have its vertical asymptotes, its imaginary boundary lines, and where is the function equal to 0, and that's where it would have its x-intercepts. So you get that for free. That's a little icing on your cake today. But hey, look, I hope you guys have a wonderful weekend. We are out of time now. Be safe, get some rest, and I will see y'all again on Monday. Live Jesus in our hearts. Okay, thank you, fellas.